KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning, students. Now in this video we are discussing elaborate information of Calvin cycle. So don't hesitate to listen. So now I am going to explain in a neat pattern. Just only one cycle I will go through like that. Why? Because so for understanding of a Calvin cycle, so this entire cycle we have to take. So like suppose if you take like a textbook cycle madri, so we cannot understand anything. So this is cycle only. So just I will go as a neat pattern. Remaining everything I will give you like in a textbook information only. Why? Because of members are they are unable to receive this neat information and all. Just only one Calvin cycle let me give. So remaining things only textbook information I will give you. Now why? Because I told you no. Suppose the Calvin cycle, if you go through the like this only, so very easily we can understand. I mean the cycle is seems to be big, but information understanding pannike is the easy method. Sarema now pathikalam. Now first of all, ribulose 1,5-bisphosphate means 3 molecules of ribulose 1,5-bisphosphate receives the atmospheric carbon dioxide. So now here the carbon dioxide, how many molecules first of all received by the or accepted by the ribulose 1,5-bisphosphate? No, 3 molecules. 3 molecules of carbon dioxide, so which is accepted or the received by the ribulose 1,5-bisphosphate with the help of Rubisco enzyme. This is Rubisco enzyme, amma. RUBISCO, Rubisco. So Rubisco is nothing but ribulose 1,5-bisphosphate, carboxylase and oxygenase. Ribulose 1,5-bisphosphate, carboxylase and oxygenase. So that is the abbreviation form of Rubisco. Now in the presence of, so when the acceptor of carbon dioxide is there, no Rubisco, ribulose 1,5-bisphosphate, by receiving the 3 molecules of carbon dioxide, so there 6 molecules of see there 3-phosphoglyceric acid formation takes place. Now 3-phosphoglyceric acid. 3-phosphoglyceric acid is formed. So this particular 3-phosphoglyceric acid simply we are taking as phosphoglyceric acid. So up to here means from the ribulose 1,5-bisphosphate to up to the formation of 3-phosphoglyceric acid. After the formation of 3-phosphoglyceric acid, we will be taking under first step, that is carboxylation. So our knowledge point of view now, the Calvin cycle can be divided into 3 types, no? Carboxylation, reduction, regeneration. So now either this first step we will be taking as carboxylation. So marandvenda. So now the ribulose 1,5-bisphosphate with the help of Rubisco enzyme by receiving of 3 molecules of carbon dioxide, so 3-phosphoglyceric acid is formed. Okay, now from here onwards reduction means the second step will be started. Now here what is the thing is happening now. So what is the thing, once you see that, now when the 6 molecules of ATP are going to be utilized, 6 molecules of ATP utilized in a further reaction. So now when the 6 molecules of ATP are involved in that reaction, now 3-phosphoglyceric acid now converted into 1,3-bisphosphoglyceric acid. 1,3-bisphosphoglyceric acid. Means 3-phosphoglyceric acid by receiving of 6 molecules of ATP, so 1,3-bisphosphoglyceric acid formation takes place. Later 1,3-bisphosphoglyceric acid with the help of NADPH or the 6 molecules of NADPH, so now it is converted into glyceraldehyde 3-phosphate pool. That is converted into glyceraldehyde 3-phosphate pool. Okay, now glyceraldehyde 3-phosphate pool is nothing but here 6 molecules of glyceraldehyde 3-phosphates are there. 6 molecules of glyceraldehyde 3-phosphates. Once you see, one glyceraldehyde 3-phosphate, next one glyceraldehyde 3-phosphate second one, and glyceraldehyde 3-phosphate third, fourth, fifth and sixth. So likewise, there are different types of 6 molecules of glyceraldehyde 3-phosphate phosphate molecules are formed. So out of 6, now 1, 2, 3, 4, 5, 6, now out of 6 only one glyceraldehyde 3-phosphate export to the cytoplasm for the synthesis of glucose. So means out of 6, one glyceraldehyde 3-phosphate export to the cytoplasm for the synthesis of glucose. Okay, so thereby if once you come back here, so means up to the formation of 6 molecules of glyceraldehyde 3-phosphate, so how many molecules of carbon dioxide is involved? How many molecules of carbon dioxide is involved means, so here 3 molecules of carbon dioxide, 3 molecules of carbon dioxide, when 3 molecules of carbon dioxide is involved, no? So there we are observing the formation of glyceraldehyde 3-phosphate pool. So now there, okay, so among the in a 6 different types of molecule or 6 molecules of glyceraldehyde 3-phosphate, one glyceraldehyde 3-phosphate export to the cytoplasm for the synthesis of glucose. But one point, what is the point we have to remember, no? One glyceraldehyde 3-phosphate molecule is not enough to form the glucose. So there two molecules of glyceraldehyde 3-phosphates are required. 2 molecules are required, but means when we have taken 6 molecules of carbon dioxide, no, one glyceraldehyde 3-phosphate moving towards the cytoplasm for the synthesis of glucose, and the second time when this cycle takes place by next time, no, at the time what is happening, again 3 molecules of carbon dioxide is received by the Rubisco enzyme. That time, no, again one more means here one more time glyceraldehyde 3-phosphate pool formation takes place on that particular cycle, and one more molecule of glyceraldehyde 3-phosphate export to the cytoplasm. So thereby already before one glyceraldehyde 3-phosphate is export to the cytoplasm, now one more is going to the cytoplasm to form the glucose. So thereby for the formation of one glucose molecule, now we are learning 2 glyceraldehyde 3-phosphate molecules are required. Means suppose if you take 3 molecules of carbon dioxide, suppose in a cycle, suppose if you take 3 molecules of carbon dioxide, this particular carbon cycle or the Calvin cycle should go by 2 times, isn't it? Means why? Because when you are going to take 3 molecules of carbon dioxide reduction point of view, so one glyceraldehyde 3-phosphate is exposed to the or exported to the cytoplasm to form the glucose, isn't it? So thereby for the formation of glucose molecule, definitely there are 2 glyceraldehyde 3-phosphate molecules are required. So thereby this particular cycle should be cycled by one more time. Means if the cycle is cycled by totally 2 times, means when if you take 3 molecules of carbon dioxide, so it will go with 2 cycles at the time, no, definitely 2 molecules of glyceraldehyde 3-phosphate is produced at the time in the cytoplasm, glucose molecule is synthesized. Okay, now remaining here 5 glyceraldehyde 3-phosphates are there now. Then what is the use of these 5 glyceraldehyde 3-phosphates, sir? Means definitely are involved in the formation of ribulose 1,5 bisphosphate. Ribulose 1,5 bisphosphate. If for the receiving of carbon dioxide, ribulose 1,5 bisphosphate is there, no? So that particular ribulose 1,5 bisphosphate is formed from the are formed by the involvement of 5 glyceraldehyde 3-phosphates. 5 glyceraldehyde 3 phosphates. Now see, first two glyceraldehyde 3 phosphates together form a fructose 6 bisphosphate or fructose bis monophosphate. Later fructose 6 bisphosphate, now it is going to be combined with the another glyceraldehyde 3 phosphate. Now two molecules are formed, one is erythrose 4 phosphate and xylulose 5 phosphate. Now erythrose 4 phosphate by mingling with the glyceraldehyde 3 phosphate, another one. So pseudoheptulose 1,7 bisphosphate is produced. Pseudoheptulose 1,7 bisphosphate is produced. Later pseudoheptulose 1,7 bisphosphate by losing of one inorganic phosphate, now it is converted into pseudoheptulose 7 phosphate. Okay, now this particular pseudoheptulose 7 phosphate, okay, so now by receiving of another glyceraldehyde 3 phosphate, now again converted into two molecules, one is ribose 5 phosphate and one more is xylulose 5 phosphate. Now ribose 5 phosphate, xylulose 5 phosphate, and here xylulose 5 phosphate, xylulose 5 phosphate. So xylulose 5 phosphate, xylulose 5 phosphate, now this one, and ribose 5 phosphate and xylulose 5 phosphate, these three molecules, so these three molecules involves in the formation of ribulose 5 phosphate, ribulose 5 phosphate. Now here the ribulose 5 phosphate is formed by the combination of three different types of molecules. Once you see ribose 5 phosphate, xylulose 5 phosphate, and here we have seen the xylulose 5 phosphate. Now here the xylulose 5 phosphate and ribose 5 phosphate and the xylulose 5 phosphate all are comes together and involved in the formation of ribulose 5 phosphate. Now the ribulose 5 phosphate, here the regeneration step. So the regeneration, so here we can write it as a third step, regeneration. The word once you observe there, regeneration. One more time formation of ribulose 1,5 bisphosphate. Why sir one more time means munnadi what happens sir means, first of all ribulose 1,5 bisphosphate by receiving 3 molecules of carbon dioxide involves in the formation of 3-phosphoglyceric acid. No, at the time there is no ribulose 1,5 bisphosphate. Why? Because this ribulose 1,5 bisphosphate is converted into phosphoglyceric acid. That's why now again by combination of 3 different types of molecules, ribulose 5 phosphate is formed. Now by receiving of 3 molecules of ATP or by utilizing of 3 molecules of ATP, again ribulose 1,5 bisphosphate molecule is formed. Okay, ribulose 1,5 bisphosphate molecule is formed. Now again this particular ribulose 1,5 bisphosphate is ready to receive the 3 molecules of carbon dioxide with the help of Rubisco enzyme. So thereby again ribulose 1,5 bisphosphate, it is ready to receive the 3 molecules of carbon dioxide. So thereby this particular cycle will be cycled. So means if you know, so from where to where we will notice the presence of carboxylation process means ribulose 1,5 bisphosphate when it is going to be involved in the formation of 3-phosphoglyceric acid from here to there. So we will be taking under the first step, and from here to remaining LMA up to the here. Okay, up to here, so remaining LMA reduction. So later from the ribulose of 5 phosphate to formation of ribulose 1,5 bisphosphate with the help of 3 molecules of ATP, we can be taken under the regeneration step. Okay, now here what are the main important points sir we have to learn means, so there Rubisco enzyme involvement is there. So in the presence of Rubisco enzyme, so definitely one in a C3 cycle in a C3 cycle 3-phosphoglyceric acid formation we see. Later why this particular Calvin cycle sir means definitely this cycle is required to the formation of glucose. Glucose definitely will be formed in the cytoplasm with the presence of 2 glyceraldehyde 3 phosphates. Now this kind of cycle when this entire cycle takes place or occurs, at the time one glyceraldehyde 3-phosphate only export to the cytoplasm. Remaining 5 glyceraldehyde 3-phosphates helps to the formation of or helps in regeneration step. Regeneration means regeneration of ribulose 1,5 bisphosphate. Okay, I hope you understood this. But here this much of sir deeply required sir means to learn the neat information point of view, definitely this kind of cycle is required. Okay, so now how these particular reactions and how in which kind of or here the 3 steps are there, no? So what is the utilization of energy forms or what is the utilization of assimilatory powers? Now let us see. That is energetics of Calvin cycle. Now for reducing 3 molecules of carbon dioxide, by Calvin cycle, now a total number of 6 molecules of NADPH and 9 molecules of ATP are required. One more time, for reducing of 3 molecules of carbon dioxide, in Calvin cycle, so 6 molecules of NADPH, and 9 molecules of ATP. Why? Because in one place, in regeneration, so 3 molecules of ATP are consumed, and in a reduction process, 6 molecules of ATP is there. In a reduction only, if you see there, in a reduction process only 6 molecules of ATP as well as 6 molecules of NADPH are utilized. Okay, so thereby in a reduction only mainly we have to focus. And if you take the first step, carboxylation, so there is no utilization of assimilatory powers. Assimilatory power is nothing but ATP and NADPH only, So thereby there is no utilization of assimilatory power in a carboxylation process. But in a reduction, when we are going to take 3 molecules of carbon dioxide in formation of phosphoglyceric acid, by taking of 3 molecules of carbon dioxide, in a reduction 6 molecules of ATP and 6 molecules of NADPHs are consumed or reduced or utilized. Okay, so now here one more information part. In order to obtain a hexose sugar, means hexose sugar is nothing but glucose. In order to obtain a hexose sugar, 12 molecules of NADPH and 18 molecules of ATP. Why? Because already I told you this particular cycle should be cycled by 2 times. So if you take 3 molecules of carbon dioxide, so this particular cycle should be cycled by 2 times. Means here initially we took 3 molecules of carbon dioxide there. So 3 molecules of carbon dioxide there. So thereby in a reduction process 6 molecules of ATP and 6 molecules of NADPH and 3 molecules of ATP are totally consumed. So thereby 6 molecules of ATP and here 3. So totally 9. And already here 6 NADPHs are consumed. So this particular cycle is cycled by one more time means this number will be doubled. Here 9 ATPs are there. It is cycled by next time means second time means. So here the number will be 18 and here the NADPH number will be doubled 12. So that is only means when this particular cycle is cycled by 2 times, then only one glucose molecule formation takes place. Okay, so why? Because sir, this particular cycle should be cycled by 2 times means here we took the presence of or acceptance of 3 molecules of carbon dioxide here. Okay, why? Because if you take 3 molecules of carbon dioxide only, then only we will know the information. We will know the information of this Calvin cycle clearly. Okay, now you see. So in order to obtain the hexose sugar, 12 molecules of NADPH and 18 molecules of ATP are required. Okay, now in first step means in carboxylation there is no involvement of ATP as well as NADPH. So there is no involvement of ATP as well as NADPH. And in a second step in a reduction point of view, for a reduction of one molecule of carbon dioxide for reduction of one molecule of carbon dioxide, so 2 molecules of ATP and 2 molecules of NADPHs are required. 3 molecules of carbon dioxide, so 6 ATP and 6 NADPHs are reduced. Means if you take 1 molecule of carbon dioxide, ATP number as well as NADPH number also reduced. No. So thereby, when we have taken the 3 molecules of carbon dioxide there, so we have seen the involvement of 6 molecules of ATP and we have seen the involvement of 6 molecules of NADPH. Likewise, when we are going to take the 1 molecule of carbon dioxide reduction point of view, so definitely 2 molecules of ATP and 2 molecules of NADPHs are required. Okay, suppose if you listen this clearly, so without any deviations, very quickly you will understand. Otherwise, practice this 2 or 3 times, then you mark all the ATP as well as NADPHs and try to mark what is a carboxylation, what is a reduction and what is a regeneration. And once with a lot of interest, if you prepare, so on the spot you will understand, at the time you will feel happy if you learn. Okay, now in a third step that is in a regeneration of RUBP there. So in third step, regeneration of RUBP point of view, 1 carbon dioxide is required. In a regeneration process now, for regeneration of 1 RUBP means ribulose 1,5-bisphosphate, there 1 molecule of ATP is required. So before I said 1 molecule of carbon dioxide, it is wrong. So 1 molecule of ATP is required. Why? Because here we have taken, suppose if you take 3 molecules of carbon dioxide, suppose if involved in the Calvin cycle means, so here 3 molecules of ATP are utilized for the regeneration we studied. Likewise, suppose if you take here 1 molecule of carbon dioxide, definitely here the number will be 1 only, no, 1 ATP only will be involved in the regeneration. Means while understanding this information, sir, where we have to concentrate mainly, sir, means, so here how many number of molecules or the carbon dioxide molecules you are taking now. So based on that, here the values means ATP utilization, NADPH utilization and ATP utilization in regeneration depends. Here we have taken 3 molecules of carbon dioxide. That's why here we are taking the utilization of first 6 molecules of ATP and 6 molecules of NADPH. Okay, and here in regeneration 3 molecules of ATP we are taking. Suppose here 6 molecules of carbon dioxide if you put means, 6 molecules of carbon dioxide if you put means, here number will be doubled, here also NADPH number will be doubled, and here the ATP number also will be doubled, isn't it? So thereby, what is the point? So if you take 1 molecule of carbon dioxide here, the number will be, ATP number will be 2, NADPH also number will be 2 and ATP number will be less. So here the 1 ATP will be there. So likewise, so how many number of carbon dioxide molecules you are taking for the reaction or the biochemical reaction, depending on that the ATP number as well as NADPH number will be changed. Okay, now you come here, so thereby, so in a final conclusion point of view, what I can give here is, in a reduction of 6 molecules of carbon dioxide, in a reduction of 6 molecules of carbon dioxide, in a reduction process, 12 molecules of ATP and 12 molecules of NADPH2 are required, or NADPH are required. Later in a regeneration, third step, reduction is second step and regeneration third step, 6 molecules of ATP only are utilized. In a regeneration, there is no involvement of NADPH. Now total pathambodhu, here 12 ATP and here the 6 ATP. So totally 18 ATP are required for the reduction of 6 molecules of carbon dioxide. Okay, and here how many number of NADPHs? So in reduction itself we are observing the involvement or the utilization of 12 molecules of NADPH. So thereby 12 molecules of NADPHs are utilized in the making of 1 molecule of glucose. So thereby when 6 molecules of carbon dioxide is going to be involved in the carbon cycle, definitely it requires 18 molecules of ATP and 12 molecules of NADPH are required. So then only 1 glucose molecule is formed in the cytoplasm. Okay, I hope you understood this explanation. Suppose if you have any doubts, so what you have to do to understand means, first by seeing the video, so this entire cycle draw it once. Okay, so later mark the labels where the ATP are going to be utilized and where the NADPH is utilized and where the another time of ATP is utilized for the process of regeneration. Once you sit there, now what you have to do is values try to put for 1 carbon dioxide first, later 2 carbon dioxide, later 3, later 6. Okay, so or 1, 3, 6 you put, so thereby you will understand clearly. So means for your understanding point of view only, here I have taken this much of a huge diagram. I hope you understood. Thank you.